On a clear night without the moon, above us, there's a sight of thousands of shimmering stars visible to the naked eye. However, this is just a fraction of what becomes apparent when observing the galaxy through powerful telescopes. The Milky Way galaxy, on its own, is estimated to host between 100 to 400 billion stars. Looking further into neighboring galaxies and beyond, there's an immeasurable abundance of stars. Welcome to Spaceverse, your gateway to the cosmos. In this captivating YouTube channel, we delve into the mysteries of the universe, exploring everything from the vastness of space to the intricacies of celestial bodies. Join us on a journey through the cosmos as we uncover the wonders of the universe, from the smallest stars to the largest galaxies. Our nearest star, the Sun, presents itself as immense, being the largest entity in our solar system, marking its presence as it rises and sets daily. Despite its apparent size dominance, the Sun is merely average in the grand scheme of the universe. There are far larger stars out there, not just marginally bigger, but significantly so. Questions arise. What is the extent of the largest star we've discovered thus far? How large can stars potentially become? And what has become of scuti? When considering the universe's largest stars, the discussion pivots on whether we measure by mass or total volume. Mass represents the amount of matter a star contains, while volume refers to the space it occupies. Interestingly, the most massive stars often lack grandiosity and sheer size, while voluminous stars may contain less matter despite their physical bulk. As stars age, they typically undergo a process of mass loss, a phenomenon observed in the Sun as it progresses in age. Approximately 5 billion years from now, after consuming its nuclear fuel, the Sun will transform into a bloated red giant, potentially engulfing the orbits of Mercury, Venus, and conceivably Earth. Despite this transformation making our Sun appear immense, there exist stars much larger. Before delving into stars with immense physical dimensions, let's examine the current largest star by mass, at 99 to 98. This star boasts an estimated mass to 126 times that of the Sun, equivalent to 226 solar masses. The mechanism behind its immense mass remains unclear, although it could stem from the merging of two stars. Scientific models indicate BAT 99 to 98's youthfulness at approximately 7.5 million years, a stark contrast to the Sun's age of 4.6 billion years. Moreover, it's shedding mass rapidly since its inception, with models suggesting a loss of 20 solar masses due to its heightened activity. Predictions foresee its demise in a catastrophic event, likely a supernova resulting in a black hole. However, despite BAT 99 to 98's colossal mass, it falls short in physical size, with an estimated radius only 37.5 times that of the Sun. It pales in comparison. A search query in Google for the largest star in the universe often yields scuti, a red supergiant once hailed as the largest in terms of physical dimensions. Initially measured to be approximately 1,700 times the size of the Sun, scuti's estimated radius was drastically revised to 775 times the size of the Sun due to an inaccuracy in its distance from Earth. This re-evaluation places scuti in closer proximity to stars like Betelgeuse or Antares, still colossal but not reigning as the largest. Presently, it doesn't even rank among the top 80 stars in terms of size. Now let's consider another star that was once thought to be the largest just a few years ago, known as Stephenson 2 to 18, a potential red hypergiant star. It was estimated to be so immense that if it were placed within our solar system, it would engulf the orbit of Saturn. Traveling around it at the speed of light would take nearly 9 hours to complete one loop, in contrast to the mere 14.5 seconds it takes to orbit the Sun. Some calculations put Stephenson 2 to 18 at about 2,150 times the radius of the Sun. However, according to stellar evolutionary theory, there might be a theoretical limit to how large stars can become, which is approximately 1,500 times the radius of the Sun. This discrepancy suggests that Stephenson 2 to May 18 they've been overestimated, potentially due to uncertainties in its distance from Earth, much like scuti, which could significantly affect its estimated size. Yet, there's no definitive equation determining a star's maximum size, as it's influenced not only by mass, but also by composition, evolutionary history, and the strength of its stellar wind. For potential giant stars like Stephenson 2 to 18, their outer atmosphere could theoretically continue to expand indefinitely. However, At a certain point, the diffuse gas of their outer layers blends with the interstellar medium, blurring the distinction of the stellar surface. Measuring the size of these colossal stars proves to be a challenging endeavor. They are incredibly vast, thousands to millions of times larger than the Sun, situated at immense distances and radiate with intense luminosity. Furthermore, their atmospheres and photospheres often extend far and are frequently veiled by massive clouds of dust, complicating efforts to determine their true dimensions. Nonetheless, astronomers utilize various factors, including distance and environmental context, to estimate their sizes, albeit with a degree of uncertainty. Based on our most reliable measurements, the current title holder for the largest star in the known universe is a red supergiant known as WG64. Situated approximately 160,000 light-years away in a neighboring satellite galaxy called the Large Magellanic Cloud, WG64 boasts an estimated radius of 1,540 times that of the Sun. This implies that if it were positioned in our solar system, it would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. Interestingly, this measured radius aligns well with the theoretical growth limit and is consistent with the sizes of many other large red supergiants observed elsewhere. WG64 is likely in the latter stages of its stellar evolution, having depleted its nuclear fuel, resulting in the expansion of its outer layers, transforming it into a true cosmic giant. Additionally, the colossal star is enveloped in a torus-shaped cloud of dust, approximately a light-year in diameter, composed of expelled material. Remarkably, it's estimated that the material within this torus cloud could produce our entire solar system 9 times over. However, despite these findings, it's uncertain whether WG64 definitively holds the title of the largest star in the known universe. Other studies have produced conflicting measurements, with one source suggesting a radius of 2,575 times that of the Sun, far exceeding even the potentially overestimated size of Stephenson 2-18. If this measurement is accurate, WG64 would easily encompass Saturn's orbit, and circling it at the speed of light would take nearly 10.5 hours, a stark contrast to the 4 hours it takes for sunlight to reach Pluto. Therefore, while the universe undoubtedly contains incredibly immense stars at various stages of evolution, pinpointing the overall largest remains elusive until more precise measurements are obtained. With continual advancements in observational techniques and technology, astronomers will be better equipped to refine their measurements and deepen their understanding of these cosmic giants. While WG64 may currently hold the title of the largest star ever observed in the known universe, the dynamic nature of astronomical research suggests that this stop spot may undergo further revisions in the future. And that's it. Thank you for joining us on this cosmic journey through Spaceverse. We hope you enjoyed exploring the mysteries of the universe with us. Don't forget to like, comment, and subscribe to stay updated on all our latest videos. Keep looking up, and may the wonders of space continue to inspire you. Until next time, keep exploring and remember, the universe is vast, but with curiosity as our guide, there's no limit to what we can discover. See you in the stars.